Sketching the graph of a cubic function. Sketch the graph of a cubic polynomial function defined by f of x equals negative x cubed plus 5x squared minus x by finding the intercepts with the axes. Find the stationary points of f of x. Finding maxima, minima, and the coordinate of the point of inflection. Looking at the behavior of y as x tends to infinity and as x tends to negative infinity. Solution. To determine the y-intercepts, we let x equal 0 and solve for y. F of x equals negative x cubed plus 5x squared minus x. F of 0 equals negative 0 cubed plus 5 times 0 squared minus 0 equals 0. This gives the point 0, 0. To determine the x-intercepts, we let y equal 0 and solve for x. 0 equals negative x cubed plus 5x squared minus x. Taking out the common factor, negative x. 0 equals negative x times x squared minus 5x plus 1. This is a quadratic equation which can be factorized using the quadratic formula. Equals 5 plus or minus root 21 over 2 equals 0,21 or 4,79. Therefore x equals 0,21, x equals 0, or x equals 4,79. Therefore the x-intercepts are 0,21, 0, 0, 0, 4,79, 0. Recall the first derivative test for stationary points. We solve f-x equals 0. f-x equals negative 3x squared plus 10x minus 1. Therefore, negative 3x squared plus 10x minus 1 equals 0. This is a quadratic equation, which can be factorized using the quadratic formula. Equals 10 plus or minus root 88 over 6. Therefore, x equals 3,23 or x equals 0,10. We have now determined the x-coordinates of the points. We can calculate the y-coordinates by substituting these values in the function. Equals 15,24 equals negative 0,05. Therefore, the stationary points are 3,23, 15,24, and 0,10, negative 0,05. f double dashed 3,23 equals negative 6 times 3,23 plus 10 equals negative 9,38, which is less than 0. Therefore, the maximum turning point is at 3,23, 15,24. f double dashed 0,10 equals negative 6 times 0,10 plus 10 equals 9,4, which is greater than 0. Therefore, the minimum turning point is at 0,10, negative 0,05. Recall the test for concavity. The graph is concave down when f double dashed x less than 0 and concave up when f double dashed x greater than 0. X greater than 1,67. Therefore, the graph is concave down when x greater than 1,67 and f double dashed x less than 0. When x less than 1,67, the graph is concave up. The graph has a point of inflection if f double dashed x equals 0. f of 1,67 equals 7,62. Therefore, 1,67, 7,62 is the point of inflection. We now have all the points that we need to sketch the graph. From the graph, we can see that as x tends to infinity, y value tends to negative infinity. Similarly, as x tends to negative infinity, y tends to positive infinity.
Need more help? Subscribe to our channel. Can't wait that long? Ask Masky to help you and let the math finally start mathing.